This video is brought to you by our sponsor PCB Way, a cheap and reliable PCB manufacturer. More about them later in the video. Hello, welcome back. This is the second episode of our PCB design tutorial, and in this episode we're gonna be continuing where we left off in part 1, and it's gonna be about the PCB layout on the actual board. So stay tuned, and hopefully this video will help you design your first PCB. It's not actually that difficult, so here we go. So what I want you to do is click on the top bar, assign footprints, and this brings out a new menu, and you can see here in the middle a list of components and these are every component that you have laid out on the PCB, on the schematic. And then here you can see the footprint name, symbol name, and then we have the value, or sometimes if it hasn't got a value, it has got the name, and then it has the final row, which is the component that will be used in the PCB layout / manufacturing. Now, these always depend on what you are creating, so the components that I have here will probably not be the same that you will have, but I just wanted to show you that this is how you would go about assigning the footprints, because without assigning any footprints you will not be able to do any PCB layouts either. So for capacitors, I have some 8085 metric SMD capacitors, and then I have selected some 5mm LEDs. And mounting holes, you need to select the correct size. I will be using M3 bolts, so I selected the M3, which is 3.2mm. Then I have the LED controller and the multiplexers. These are my custom footprints. And the through hole pads, you want to select a test point, THD pad, and then the D2 is the size of the hole pad with the copper layer, and then the drill is 1mm, and this would be 1mm hole with 0.5mm copper surrounding it, so total 2mm copper. So you select all of the components here, you click on the symbol or the row here, and then on the side we have filtered footprints. On top here you can go ahead and search. You would search for a capacitor. Then we have a list of capacitors. On the side here you select the one that you need. Here you can see that I've selected this one. You double click it. It shows here. Then you click apply, save schematic, and continue. And once all of the footprints are done, you click OK, and that's done. And then you are done and ready to move to the PCB editor. Move to the PCB editor by clicking the switch to PCB editor button, and that will automatically open the PCB window for you. So now that the PCB editor is open, you can see we have an empty slate here with nothing in here. This is similar looking to the PCB schematic editor, but instead of the side menu here having the schematic buttons, we instead have the footprints, routes, vias, fill zones, etc. And then on the very side we also have the layers, objects, and nets, but the most important will be the layers. Now, something that you want to maybe check, but usually with KiCAD it's already all good, is go ahead and select the board setup from the file menu, and here you can see the editor layers. The stack up is the most important, with the PCB that I'm doing is we're doing a 2-layer PCB. Here you can select how many layers you want. You could, with KiCAD, you could basically go up to 32 layers. Keep it simple, try to make it as little layers as possible, and don't really need to worry about most of these settings. It's usually good already. You could set the board thickness here and whatnot. You can see the dielectric core material for 4, and then we have the coppers and top solder mask, top solder paste, silk screen, which is a text, and same for the bottom. These are something that you want to check, but generally they will be exactly as you want them. So the way you bring in your components is by clicking Update PCB from Schematic, or the shortcut would be F8, and you can see it checks that there's no errors, which there are none. If there was, you would want to fix those errors, but there should not be, since we ran the ERC and we have all of our components footprints selected. So we can update PCB, you can click close, and it brings an array of the components like this. And it's very obvious this is not how we want to have our parts, but this is where the fun part really begins. So first things first, after the components are exported, you want to define the confines of the area that you are going to be working with. In my case, we have a very specific size limit for the PCB, since there is not a lot of space and the components need to be in a specific spots. And generally speaking, smaller is better, since smaller is cheaper. So what you want to do, select on the side here on the layers the layer called edge cuts. You select the edge cuts layer, you select the rectangle, or technically if your PCB was not a rectangle but a circle or a polygon, you could select any of these, but for me it's gonna be a polygon. So I just want to go here and draw a square. Now for the size, I don't really care right now what the size is. I'm just gonna click like so, and then I'm gonna double click the rectangle, and you can see that we have our location and height and width. What I want to do to keep things simple is set the starting point to 0, and then you can see that it jumps into the 0 at the corner of the page. And then we want to set the height and the width to what we want them to be. For our PCB, we're going to be looking at 42 millimeters by 100 millimeters, and that's the PCB. Now, I know it's a little bit annoying that it is on the side here. I'm not sure if there's a way to set the origin a little bit better. Maybe there is, but the reason that I want the PCB to start from the 0 corner is so that now that I'm gonna be picking up my tactile switches, I can double click the component. It brings me this menu, footprint properties, and down here we have position. And by calculations, I can precisely figure out what position coordinates I need here to have my tactile switch in the precise position that I want it to be in. I don't remember what the specific spot is, so I'm just gonna do something about 20 and about 27, and it places it around there. If you are just creating a PCB without any specific placements in mind or specific requirements, This is gonna be way easier and you can do this way simpler. But what you wanna do is go ahead and sort of put everything where you need them to be. So one thing you wanna keep in mind is when you pick these components, place them here. D5 is here, and then you might expect D6 to go here. But looking at the schematic that we created, we can actually see that for whatever reason, D6 is actually here, and D7 here, and D8 here. It's very easy to mistake, to assume something to be in a specific way, and then that can cost you a lot of time to figure out why things aren't lining up, or even cost you money if you order the PCB and components are in the wrong place. Now, since I have now the key components in the correct places, or we can at least pretend that they are, I'm gonna bring the PCB into the center. Just something I like to do. Now, you just want to be placing components to wherever you find place. Again, click R to rotate to find more space. It is going to be very difficult sometimes to find a correct spot, place where the fit is. But eventually, after figuring it out, things will work. What I'm going to do is place all the components to around where I want them. They don't need to be specific, but just somewhere where they fit the PCB. And when I'm done with that, I'm going to come back and show you how to do the routing. Before continuing, we would like to tell you a little more about our sponsor, PCBWay.
PCBWay is a part manufacturer who offers PCB manufacturing and assembly, CNC machining and 3D printing services.
Their low prices and endless customization enables everyone to use their services in a moment's notice.
We have already ordered some parts for this project and it was very convenient and easy process.
Go check them out from the first link in the description.
Thank you PCBWay for sponsoring this segment. And back to the video.
Alright, so now I have all the components, everything laid out where I want them to be. And you can see that it's pretty cramped, but it's actually not that bad. Just looking at some professionally made PCBs, they could cut the size way more down and have things way more compact. But since it doesn't really matter for me, and this is the PCB size I want, this works just fine. All the components in their place, it's time to start wiring them up. So one thing that you need to do before starting to add wires is define some track widths here. Now, what common widths for tracks are is 0.25, 0.5 and 1 millimeters. Now in my design I will already say that I will not be using 1 millimeter tracks. That's way too large for anything I'll need, so I'm just gonna get rid of it. But 0.25 and 0.5 millimeters in mils shown here, about 10 and 20 mils, are pretty good track sizes for the work that I'm doing. And you need to realize that the smaller the track width is, the more expensive, or actually, if you go very small track widths, it's gonna be costing actually more than with wider tracks. And generally speaking, wider tracks shouldn't cost more, since it doesn't really work when PCB manufacturing doesn't really work that way, that the more copper you have exposed, the more it costs. It's generally you want to use as large tracks as you need and can have, but also maybe don't go too crazy with them. There's no benefit if you go way too crazy. 2.5 for signals and 0.5 for my power is what I have chosen for this design, and those generally work for me. Now with these predefined tracks, you can do is cycle the tracks with W. So again, another shortcut, so you don't need to go here and select which one you use. You just click W and it cycles through all your tracks. Now adding wires is as simple as clicking X, and then you can see that once you have the wire here running, it sort of routes it wherever you bring it without colliding into your parts. But obviously you can see that this is where we need to put this. You just click here and it connects. It highlights the correct pad, and you cannot connect it to the wrong pad, which is a nice feature, and obviously very good visual cue for you where to bring your wires. Here you can see all of your VCCs, but obviously you want to go to the closest one. Another thing that technically doesn't really matter, but you might want to utilize, is there is different sort of grid densities here. I use the 0.05 mil, so I can basically put a point anywhere I want. Sometimes you could use the 0.5 millimeter, which sort of snaps to the grid very nicely, so it runs very clearly, but that might be a problem sometimes when you are routing through very thin places, multiple wires. So I like to use the 0.05, which gives me a lot of smoothness and lots of options to put my wires in. Another thing that KiCAD does automatically, it sets you a limit to how close wires and components can collide or go to, and that is indicated by the gray area. And you can see that it won't let me put the wire close to the pads, and it's limited by the gray area, not by the red area, which is the wire itself. And on the settings menu you can adjust that clearance, but that one that KiCAD has automatically set is, in my opinion, just fine for what we are doing on this not so precise PCBs. I would imagine, but I'm not exactly sure, bigger clearance is more safety margin, less interference on the lines, but the default clearance should be fine. Now the blue wires indicate unconnected pads, and they show you where the connection should be made. For example, here we have a very simple line going right there, again right there, right there, and this is basically what you need to do for every single component. Things can get very difficult, but one thing you need to realize is you can always go underneath the components, so you're not confined to the outer limits here, but you can go in here, you can go through there. The only restriction is the restriction that KiCAD has, and that is that you cannot cross from the through hole mount, and you cannot go through SMD pads, except if you create a via, which you do by clicking V, and it brings this sort of hole icon here. Now let me just drop this to here. You can click, and it now switches to the bottom layer, which is indicated by the blue, and then with the blue color you can go underneath even SMD pads, since these are on the top layer and we are on the bottom layer. Now one thing though you need to realize is that when you are on the bottom you cannot connect to SMD pads on top, but you can connect to through hole, well, let me just bring it here. You can connect to through hole mounts, since those are on both layers, and you cannot cross through hole mounts because exactly they are on both layers. So that's essentially the basics. Now it would be very boring for me to show the whole thing, because this usually just takes a lot of sort of testing out the best way to put things. Generally you can, or you should just find the easy connections, the clear connections first. You can see that's very clear, and basically you can see that that is going to be the best way to route this. Then you could go like so and like so, but at some point you will have a lot of wires going all around, and you will need to start to adjust already existing places. You need to add a lot of wires, so go to the bottom layer, back to top layer. Try to keep the wires as short as possible, so you know it's just gonna be the simplest route that you can take usually, or you should try to make the shortest route that you can. But sometimes you might need to go a little detour around the board, and that's okay. Just, if possible, try to find the best way. And sometimes you just have to do some really stupid wiring, like here I have to connect here, so you just might have to go around all the way here and create something weird like this, since there's no other way. Although here, what I would do is here put a wire, go underneath, but not a wire, and turn up here, and now we have our VCC connected there. Just remember, utilize your wires, go underneath things, use all the space that's available, use thinner tracks if you need to, and try to find the optimal way. Sometimes just make some random connections, try to get everything connected, and then after the fact you can start to correct things. I'm gonna connect them off camera, and we're gonna come back and see what we need to do after everything is connected. So here we are with all of my tracks drawn, and you can see what I was talking about here. Things can get very cramped. We have a lot of wires going on top of each other. We have to use bottom layers and top layers going all over the place. Lots of vias going across like so, and it looks very complicated, but in the process things just kind of start to flow together as you get further, and eventually you will find the road to every connection. And once you have everything connected, you can already kind of see we don't have any blue wires, missing connections or anything like that, which is good. And again, similar to the design page, the schematic design page, we have a design route check on here as well, called DRC, and you want to do this as well. Also, it's not always checked, but you want to check the test for parity between PCB and schematic, and this just checks that the schematic and the PCB are exactly the same. Sometimes there are some naming issues, or maybe you have accidentally duplicated a connector, and now you have too many connectors here. Yeah, some weird parity issues could be happening. I'm gonna run the DRC, and you can see that I don't have any violations, no issues. I also don't have any unconnected items, so I'm not missing anything here. If I was to disconnect, let's say, the test point 13 down here, I just removed that track from the DRC, it's gonna give me an error on unconnected items, and then you can click, I can go over here, I can click, and it brings me to the error. It shows me this is not connected, you need to connect it, and then I can just go ahead and connect it. And run the DRC again. And no issues, no schematic parities. There are some ignored tests, you don't have to worry about these, definitely. You don't need to worry about these generally, since I don't even know what bit HE and bit T and these really mean. I mean, you could turn on the footprint component type as a master footprint path. You could turn that on. I'm not really sure what the benefit would be though. You know the components that you have selected, so. And similar, this footprint has no courtyard defined. There's really no reason that you need to have this enabled, which is why it is ignored. But if you wanted to have those on, you could turn them on, and then that would also show the test. Since there are no errors, we are all good. We are not done yet though. Even though all of our connectors are done, what we want to do is create something called ground pour, or it could be any pour, but we're going to do a copper fill, or there are many names to it. I'm not really sure what's the official or the best name to call it, but I just call it a ground pour. You need to click on the add filled zone button here, and then click on the PCB. I just clicked here for now, and you need to select the back or the front. Let's create one on the back right now, and then you select the net, and obviously we are talking about ground pour. We would want to select the ground. For now, no need to worry about all of these things. Just click OK. So you can just draw your shape like so. Go in here, connect it, and you can see that now the area is marked like this. Now I have already done them, so we can go here. I'm gonna look at the top layer and live with the zone. So you can see that the ground pour looks like this. The red area is indicating where we will have our ground pour. This should decrease, as I understand it, this should decrease all sorts of interference, and generally is done at professional applications, so you should probably do it too. Maybe look into this if you're not sure. I'm not a professional. This is something that I have seen others do, and I think is something you should also do. It's not difficult to do. Just add the zone around your whole PCB, make it a ground, and then to generate it, you actually need to click B, and B, like Bravo, updates the ground pour, and if you made some changes, you would need to regenerate it by clicking B each time. You can also do a similar pour on the backside, and that would look like this on the blue. This is a 12 volt zone here, and the reason it is only in this area is this is where I have my power output stuff. I only wanted to put it here. I tried to put it around the whole thing, which technically would have been better, but it was giving me too much error, so I just thought, let's just put it down here. I don't care. It's not that this is not mandatory. This is just something extra. So I just decided to do this. Now, the last thing before we start to do the extract or export settings is you want to make sure that your silk screen layer, which is the sort of yellowish color, is good. So essentially what the silk screen is all the text drawn on the PCB, and that means all of your component names, and if you want to, you can have the outlines of the LEDs, switches, things like that. A lot of this is generated automatically, but you just want to make sure that the things are placed where you want them to be. So this one should not be placed here, because then it would be underneath the switch, and that's not gonna be any helpful. Just have it there so you can see it. And of course it would be bad if there would be anything outside the defined edge cut. So you just want to have it just close to the components. and these will help you assemble the PCB when it arrives to you. But once everything is checked good and you run your DRC one last time and it comes to no errors, or any errors that you see that you don't care to fix that are fine, are resolved and it's good, then you want to export this. But that will be the subject of the next video, where we'll also order the PCB from PCBWay and assemble the PCB as well as test how it works. So stay tuned, subscribe, click that bell notification to receive a notification when the video arrives. Leave a like, ask anything in the comments, and we'll see you in the next one. Thank you PCBWay, see you in the next one. Goodbye.